Hello, my students. Today I need to talk about databases. It's part 2 in Unit 1. It's about the Java fundamentals. And you need to keep in mind that when we finish our own class diagrams, we need to make sure that when we have entity classes, we're going to have one-to-one map between the class and tables and the database. So now we need to learn what they mean by databases, what they mean by tables, and then we can be able to link or associate the classes with the tables. This is the topic for our unit today. I just need to know why do we need databases or database management system, as long as we can save some information in just text files or binary files. What we have learned so far during the first year course, you learned how to create or how to open a file, a sequential file or text file, and how to store some data and retrieve from that data. But there is some limitation for using such tables. When it comes that we need to store a huge amount of data, then it is not easy to do some searching or sorting or filtering for this kind of text files. So in this case, we need some external help, and there is many such tools, and we call them database management systems. We need to cover today in this unit. For a relational database management system. So later on, you're going to learn that even the database management system has multiple types, and the type that we're going to cover in this unit is simply relational database management system. It's no more than a software. It uses it as a tool to help us to store our data in some structured way, and that structured way help us to do filtering, searching, retrieving data in a very fast way, even so we may have huge amount of data saved in the database. Now we need to learn how we create tables in these such database systems and how we store and retrieve in an easy way using Java programming language. So in order to do so, I have here, you can look at this in this diagram. We have our own Java application that we use in order to write our own applications. We're going to use what we call a database management system. This database system is going to help us to store some information in the data. We don't really care how the structured, but this is going to be structured in a way that maintained and controlled by these management systems. This management system is going to expose some APIs, some functionality that we can call it from our Java application so that we can store data here or we can retrieve it later on. So the application sends commands. During our coding, we're going to send commands from our Java application. This command should need to be understood or follow the same format or the syntax of the database command. Then the database management system will understand these commands, and then based on the command, we're going to store or retrieve data. And then if we need to restore something, then the output will be sent back to the application from the database system. If we need to save something, Java is going to send this data to be saved, and the database is going to take care about how to save it in a way that later on we can retrieve it in some fast and professional way. So this is just the structure how we're going to deal with the databases. Only what we're going to learn is how Java can connect to database. Once we have a connection, how we can form a command, how we can send the command. And after we send the command, how can we read the result coming back from that command and can use it or display it later on in our applications. In order to do so, there is Java Database Management System, or JDBC. This is simply another class that translates the command we write it in Java to be understood by the database management system. And we're going to use these classes in order to connect to the database and in order to send and receive commands. So we're going to use a structured query language. We call it SQL language. So SQL, we pronounce it SQL. So this stands for structured query language. This is the language we're going to use to form the commands from our Java application to be sent to the database management system. So it's standard language by most of the database management systems. It's not for general programming purposes like Java or C# or C++. It's specific for database management systems. It consists of a number of keywords understood by this DBMS. It's about queries or inserting data or retrieving data from the database. And in this unit, we need to learn about SQL commands or SQL language. The list here show you the most common famous database management system exists and used by the developers. We have Oracle. So we have Oracle Database Management System. We have from Microsoft SQL Server. And from IBM, we have DB2. And also we have open source MySQL database. And we have also JavaDB. And we're going to learn JavaDB in this course. We need to talk about now tables, rows, and columns, and the database itself. You need to imagine that database is simply consists of number of tables. So if this is our database, then our database is going to have one or more tables. So we have here table 1, table 2, table 6, and each table consists of number of rows. So this is row 1, row 2, row 3, and so on. Each row is divided into columns. Then we have here column 1, column 2, and column 3. So this is the terms and the terminology I'm going to use for database. Any database management system, whether it is Oracle DB2 or any other database management system, have the same terms and terminology. If this is your database system, database is going to have multiple tables, and each table is divided into a number of rows. Each row can divide it into a number of columns. And if you need to compare this to UML diagram or UML class diagrams, you can say here, each table corresponds to one class. And in your class, we have number of attributes, number of fields. Each field is correspond to one column. So table is a class, is an entity class. Each attribute in the class represents one single column in the table. And then every row in the table represents one single object as an instance of that class. And more in this later on. But this is here the terms or the terminology we use for database management systems. This slide here shows you an example of data in one table. If I say that I have a table called coffee in my database, I can see here I have 3 columns in that table. So we have description column, we have product number column, and price. And then here we have rows. Each row represents different value or different data in this table. So this is just one table, has number of rows, and this rows is divided into 3 columns. And this is here the column title or the column name, description, product number, and price. And this is the data here. If you need to compare this with a class, that means this is here one UML class. And in that class, we have an attribute called description. We have an attribute called product number, another attribute called price. And each of these data represent an objects of that class. We have data type, and when we see that we have attributes or fields in the class, we define them in specific type. So we have the same thing here for the database. The columns also need to have a specific type. So we have integer, we can use the keyword integer or just int that represents integer that is correspond to the Java. We char or character. It might be with specific length. This is correspond to a string. We can see here I have a char 10. That means I have a string that has maximum 10 characters. We have varchar. It's also for a string. And varchar here can also have a number. So we can see we have something like this. I have a char 10. That means I have a string of length 10. And here we have varchar. We can also have varchar 10. Both are string columns. So what's the difference between both of them? The first one here, when you say char 10, it reserves 10 locations, 10 characters, or 10 positions for every single value in the column, whether we fill it with information or not. So we may have here this column of chart 10, and then I just has only 2 characters, but the database is going to reserve 10 characters for it. Here, when you say varchar from its name, that means it is variable, it's not static. That means if the column is 10, they can hold up to 10 characters. But if I have a value that has only 2 characters, then I'm going to reserve only 2 characters for that column, not necessary to be 10. That means it's up to 10. But if we have less than 10, then going to have this less number to be reserved for in the database. This is the main difference between char and varchar. We have also real to represent floats and double. So we have also 2 different equivalent to float and double. And we have also here decimal. This is represent to what we call it big decimal. If we need to represent something more than 32 bits or 64 bits, then we use the type decimal. Dates, and this is represents the dates. If we need to have equivalent to this, we use java.sql.date. It's another definition from API of library called SQL or SQL library. So here in the slide, give you some example how we use char. So we have here the description based on our coffee table. We define description as character or a string of length 25. We define product number is another string of length 10, and the price here defined as double. We have what's called primary keys. When we create a tables, and then we define number of columns in each table, then we need also to define which column act as a primary key or primary keys. So what's the purpose for the primary key? It's simply to define the key that act as unique identification for the data. When we define a column as primary key column, that means its values are unique. There is no duplication in that value. And we use this primary key to help us to have search and sort. If we need to retrieve some data based on some values, and we need to have the result very quick, then we need to define some primary keys in your table. Primary keys, that mean it's a column, exists in the same table, and that column has unique values. There is no duplication in that column. And in this case, we use that column to help facilitate searching, sorting, filtering in very fast way. And now we know what the primary key. We may have multiple columns defined as primary key as well. So if this is here your table, and your table has multiple columns, and we said that okay, this should be my primary key. Let us say the ID of the user. We may have a compound key. We may have 2 or 3 columns. All of them act as one primary key. That means when we combine all these 3 values, then these are unique. And in order to be able to retrieve data, we need to provide the value for these 3 columns act as one key. So we may have compound key or one column key, but it's still, we call it primary key. And keep in mind that if you need to do combination like this, you need to make sure that there is no duplication. We'll never find 3 consequence values repeated in columns. So we cannot find these values somewhere here. So let us now go to the syntax of the commands and learn also how to provide these commands from Java application. So assuming that we have this running example, we have this table. The coffee table has description, product number, and price, and we have here number of data. If we need to retrieve some information from this table, we use the command select. This is the most common command in any SQL language. We select a number of columns, 1 or more, from a specific table. This is the general format. To select information from the column description in my table, I write the command select, and then I write here the column name and the keyword from, and then the table name. This command here will go to retrieve all these data. That the entire column data will be retrieved to my application. This example here, we write select description, comma price. That means I need to retrieve information from the column description and from the column price from the table coffee. That means when I execute this command, we're going to retrieve all the information from description and the price in one command. If I need to retrieve the whole data stored in the table, I'm using here a star. That means every single column needs to be considered. So I'm going to write here, select star from coffee. This will return all data in this table. SQL commands are free form. We can use small letter or all caps or combination between a small letter or capital letters. And we can write it in one single line or multiple lines as well. So it doesn't matter here. At the end, we need to have one complete correct command. And you can see here we have select all lowercase letters. We have select here all uppercase letter, and we have a combination for them. But keep in mind that when we have here, look at this, table coffee started by capital C. This is the name of the table and should be the same like this. The name of the table is sensitive. So if I name it in the first hand as starting by capital C, I have to write it here capital C. So this is not a keyword. This is the name of the table. Same thing, the name of the columns should be the same format we defined the table in the first place. So how we're going to send the command to the database from Java? First of all, we need to connect. We need to connect to the database. Then we can use this connection to send the command. So first of all, we need to create a connection. To create a connection, we're going to use the class or the static method get connection from a class driver manager. First of all, I need to define where my application can find the database. So I have something like this here to say that my database, I'm using here Java database connectivity, have it as a Java library, help me to connect to the database. And its database is Derby database. And I write here the database name, CoffeeDB, and assuming that it is within the default folder in my application. For now, create equal true. That means each time we create a table, if the table is not exist, we create a new one. If the table exists, we're going to override the new one. We're going to override the existing one by the new one. So we write here the string, just like define the path where to find the database. And then we use this string through the static method get connection from the class driver manager. This class defined in the database jar, we downloaded from that website and you add it in your project structure. And right here, the URL, this is simply the path for your connection. Then you have an object, I call it here con, and of type connection. And again, this class is defined inside that jar file we downloaded from that link. So now I have a connection. Now this object defined or refers to the connection between my application to this database. Then later on, I'm going to use this object in order to send commands. So to send the commands, we need to send a statement. To send a statement, we need to create an object of type statement. So what we're going to do, we're going to use the command objects and call the method create statement. This is where return an object of type statement. And I call my object here a statement or STMT. Then again, we use the object that referred to the connection to the database. That object has a method called create statement. This will return an object of type statement. I call it here STMT. This object, now I'm going to use it in order to define my statement or the SQL statement to be sent to the database. So now let us say I need to send the command select description from coffee. This is one valid SQL command. So I added here as a string. I defined as a string. Notice here we have double quotes. And this is simply just normal Java string variable. Then I'm going to use this object, which is of type statement. And then I'm calling the method execute query. This method defined in that object. So statement.execute query. Then I need to feed here my SQL command that's defined as this string. It should be valid SQL command defined as a string variable, and then send it here as a parameter to the execute query. Then the GDBC, we're going to send this to the database to say that we need to retrieve the description information from the coffee table. And the outputs are going to be saved in another object. I name it here results. I have to use the class result set. And the result set here, again, another class defined in that jar file. So I have now my object called results. And this is simply something like a matrix or 2D array. It's just a matrix of type result set. So the result set is no more than 2D array. And later on, I'm going to learn how we retrieve from such 2D array. But now this is now inside my main memory in my Java application. It's 2D array having all this information that retrieved from that command. So our result set, as I mentioned, it's about matrix or 2D array, something like this, number of rows and number of columns. And based on what I send as a command, they retrieve me to say that this is what we have, assuming that this is what we have in the database. And then I send a select star from the database, and they give me the 3 columns with all the data. Once we retrieve the information, we have what's called cursor, or the position where we currently in the table. Once we have the results back to our application, it came to us in this format, and then the position of the cursor is simply immediately behind the first line. This object has internal cursor. It simply points to specific rows which row that we need to read. Initially, it starts at that position that is immediately before the first line or the first row in the table. And then we move on from top to bottom. And the default movement is from top to bottom. This is the default mode. But there is other mode that we can jump to the rows, or we can moving backward and forward. And we're going to learn about this later in this slide. In order to read the first line, we use the function next. And simply we call this function from our object results, and that from the result set. Each time we call the method next, the cursor moving one position down. The effect of this method is simply moving the cursor in the rows, but not to retrieve data. So each time we call next, we move one position down without retrieving any data, but just moving the cursor. In order to get the data, we need to send another method to get the data. Here, you need to know that result.next return a Boolean variable, which is true or false. And this is here the template that if you need to read the entire information in this 2D array, we can have something like this while the results.next true process this data. We keep doing so unless we reach to the end of this 2D array. That means this is going to be evaluate false. So as long as it is evaluate true, that means we have a row to read. When it is false, that means we reach to the end of the table. And you're going to use this also in your code. To read what we have on that row, we use the method get. And get depends on the type of the column. We have get string, we have get double, we have get int. So in this example here, I need to get the value. Let us now assume that I'm here and I'm in this location. Now the cursor is pointing to this one. And now I have 3 columns. This is column 1, this is column 2, and this is column 3. To get the data in the column 1, I need to call the function get. And if this is string, I call the function get string. If this is double, I need to call the function get double. And sending here the column index. We can use index, we can use column name as well. So here in this example, I'm using here, I try to write the result to get string, the information in the column 1 in the current position of the cursor. And here I need to print the second value, or the value of the second column. And here I need to write the value of the third column. And notice that here I'm using get double because it's defined as double, the column type defined as double in this table. I can use numbers to indicate the index of the columns, or I can use the column names. So I'm using here description, product number, price. And notice that here I have to write it the same format I defined in my table. This table here shows that we have what's we call get double, we have get int, we have get string, and this is the most common get method we're going to use in our course. All right, so let us now take more examples about select statements. So we need to learn about that we may retrieve some part of the data, not the entire data. What we learned so far, we retrieve the whole data in description column. Let us say that I need to retrieve sub data or range of the data in my table. So I'm going to use the keyword or the phrase where, and then writing here the criteria. The criteria should be evaluate true or false. It's simply a Boolean expression. So in this example here, I have select star from coffee where price greater than 12.0. This is say that I need to retrieve all columns because of the star from table named coffee where this condition is true. Give me all the rows in this table that has the price greater than 12. Then you can expect this is the results in the result set. Two-dimensional array again, and we have only two. A record has been retrieved from this command because their price is greater than 12. All other prices less or equal to 12. This is the way how we can specify specific range or portion or subsets based on the criteria. So we can use greater than, less than, greater than or equal. Notice here the annotations. Some of them is equivalent or similar to Java. Other is not like this. Equal is simply just one equal sign. Not equal, we have here less than, greater than, combined. So this is here the operator symbols we use for building some criteria. And again, you need to make sure that it at the end evaluate true or false. We also can use, you can see here, I'm using just one single equal sign. And it just I need to look at this here. I'm using simple code, one single code, one single code. It's very important to notice here because most of the students they didn't differentiate between single quote and double quotes. If you write the double quote in this statement, that means this is wrong. It's not acceptable by SQL command. It should be single quote to include the string values. So we have here, see that give me all the columns in the coffee table where description is equal to French rose dark. So again, keep in mind that it should be a single quotes, not double quotes. Notice that here, this is here case sensitive. That means it's going to look at all description that start by the word French and start by capital letter F, and also for roast and dark. But if we have some data like this, then we're not going to match this and make it equal because it is here case sensitive. If we need to retrieve all description, whether it is started by uppercase F or lowercase f, then you can use some functions, redefined function in SQL command as well. Something like here upper method. Upper that say that between the brackets, convert everything here in this string to all uppercase letters. And then you can say, okay, compare it with French roasted dark with all caps. That means we're going to take this value and this value, convert it all to uppercase characters, and then compare it with this. In this case, we're going to retrieve both of them. So we have upper, we have lower. This is help us to do this kind of comparison. If the string itself, for example, has here apostrophe S, that means in this case, this is conflict between this single quote and this single quote. So in this case, you need to write here two double quotes, two single quotes. It's not one double quote, it's two characters. So that lets the compiler know that this is mean that it's just one single quote. We also can use the like operator. In the previous example here, I compared the full text. If I need, for example, to retrieve all description that start by first letter only French and anything else, in this case, I need to use the operator like. So look at this example here. I have select star from coffee where description like, and then between two single quotes, percent decay. Let's say that retrieve all lines that has the description started by any combination of characters, followed by DECAF, followed by any combination of other characters. What it doesn't matter about the length. So any combination of characters followed by DECAF and followed by any combination of characters, 0 or more. We have also here wildcard symbols. If we need to represent just one character, then I'm using here the underscore symbol. This is say here, try to find all the fields that the product number start by 2 and any character here followed by dash, followed by 00, followed by one single character here. So this underscore, it's wildcard for one single character. Doesn't matter the value for that character, any character will going to be considered true. If you need to say doesn't like, that means give me all the description that doesn't have the cave in between, then you use the keyword here, not. We also can use the phrase order by to do some sorting. Say that I need all the data from the table coffee and I need them sorted by the price. Sorted that the lowest price in the top and the highest price in the bottom. So simply I use the keyword here, order by, and there is a space between R and B. So here in this command, select star from coffee order by price, want to retrieve all data in the table coffee and sort it by the price, thus the lowest value of the price in the top and the highest value in the bottom. If I need to sort them in descending order, then I write here order by, again the same way, and then the column name, and then the phrase descend or descending, DESC. So say that both the highest value of the price in the top and the lowest in the bottom. This is again going to retrieve all data in the coffee table where the price is greater than 9.95. In addition, I need to sort what we're going to retrieve in descending order. We also can have another method like average, sum, minimum, maximum. Let us say here I need to retrieve the data so that I don't need to give me all the data line by line, but I need to you need to do some calculation and give me just the results. So consider all this data and do the calculation, add all of them up and then divide them to their number. That say I need the average of all the prices. So you can use here average methods, AVG, and say the column name here. That means this command will consider all prices and calculate the average of all prices and return one line as a result, which has only one value, which is the average of all prices exists in the table. You can have just the sum. You can say, give me the total amount of all prices exists in this table. You can also use minimum to say that give me the minimum price in the same table or give me the maximum price of this table. If we need to count how many lines or the size of the data in this table, count how many lines here, we use the phrase count star. That means say that give me the size of the table currently exists in the database. Count star this format, we're going to return the size of the table. Let us say here, this is 20 or 30, or give me just the number or integer number to the computer memory. I need to stop here. Thank you so much.